The standard form of a circle equation is given at the top of the page. It is x minus h squared plus y minus k squared equals r squared, where h represents the horizontal position or location of the center of the circle, k represents the vertical position of the center of the circle, and r represents the radius of the circle. We'd like to look at the circle that's graphed and see if we can determine h, k, and r just by looking at it. So h and k represent the coordinates of the center of that circle. So if we just identify what the coordinates are, it looks like it's 2, 1 here. In this case, h is going to be the horizontal location of the center, and k will be the vertical location of the center. And that's all we have to put here, is that h is 2 and k is 1. Now r will be the radius, which is the distance from center to any point on the circle's circumference. So we can see here that the radius appears to be 3, and that's what we'll put here. Now we'd like to write the equation of this circle in standard form. So just to copy the equation, it's x minus h squared plus y minus k squared equals r squared. Now let's fill in the values of h, k, and r. The formula does include minuses, so we need x minus 2. We need y minus 1 squared, and we'll put in 3 squared. And that's our circle equation. We can verify that it's correct just by going to a graphing program such as Desmos.com, and we'll type in that equation and see if it plots the same circle that we see here in our graph. X minus 2 squared plus y minus 1 squared equals 3 squared. It looks like the same circle as we see in the picture here. Great. Let's find the equation of a circle whose radius is radical 5 and whose center is at 8, 7. So in this problem, they're giving us the r value. They're also giving us the h and the k. And we just have to put it into the right place in the formula. The formula says x minus h squared plus y minus k squared equals r squared. So we'll have x minus 8 squared plus y minus 7 squared equals radical 5 squared. We could simplify that if we wish. And there's our circle equation. Here we're asked to find the center and radius of a circle, whose equation is given below. So remember that the standard form had said x minus h. But here we don't have a minus, we have a plus. So that implies to me that h is not actually 2/3, but it must actually be negative 2/3. Because that way the two negatives would cancel out to make a positive. But for our k value, our k is just 4/9. We have subtraction in the circle formula, and we have subtraction in our standard form. So k is 4/9. Now r is a little tricky because in our standard form, we have a r squared. So r is not 49/4. Instead, what we have is r squared is 49/4. That's the thing that's in the place of r squared is 49/4. So we actually, if we want to find r, we want to take the square root of 49/4. So that's going to be 7/2. Here we'd like to find the equation of a circle that passes through 5, 4, and whose center is at -8, -5. So this one's a little bit more in depth. We have to do a couple steps to get this equation. Equation says x minus h squared plus y minus k squared equals r squared. So right away we can fill in the values of h and k, which is nice. We have a double negative there, and there's a double negative here as well. But it looks like the toughest part is going to be finding the r value. So if you have a center h comma k, and there's a point that the circle touches, 5, 4, then we ought to be able to find the distance between those 2 points using the distance formula. And that distance will be r. So our r is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula between 2 points in the two-dimensional coordinate plane. So our r will be square root of 4 minus -5 squared plus 5 minus -8 squared. That's the square root of 9 squared plus 13 squared. Which is the square root of 81 plus 169. It's the square root of 250. Alright, now that we know r, we can plug it in. And we'll have the square root of 250 squared. So we might as well simplify that. The square root and the square will cancel. And we can simplify these double negatives as well. So we'll have x plus 8 squared plus y plus 5 squared equals 250. We can just verify with a graphing program if the circle that we've described here really does go through the points that they said. It should have a center at -8, -5, and it should touch the point 5, 4. Let's see if that's true. Okay, it looks like this circle does likely have a center at -8, which would be here, -5. Yeah, we can even plot that point. Yeah, that looks pretty reasonable as the center of our circle. Now let's plot the point that they said it goes through, which is 5, 4. Yeah, that point is right on the circumference of our circle, so it looks like we did it correctly.